Welcome to this beginner's guide to Unity's Entity Component System, ECS, and the data-oriented technology stack, DOTS. We'll explore how these powerful tools revolutionize high-performance game development. Including the Burst compiler and C# job system, revolutionize game development. They emphasize performance and scalability, enabling more ambitious and complex game worlds than ever before. ECS is a modern architectural approach for game development, focusing on data-oriented design. This is crucial for achieving high performance, optimizing how data is stored and processed for maximum efficiency in complex games. ECS is a core part of Unity's DOTS, which also includes the C# job system for multithreading. It also integrates the Burst compiler for optimized native code generation, ensuring your game runs at peak efficiency. ECS is particularly beneficial for games with a large number of entities on screen simultaneously. It handles hundreds of enemies or thousands of particles with remarkable efficiency, ensuring smooth and fluid gameplay without performance bottlenecks. Let's dive into the core concepts: entities, components, and systems. Understanding these three fundamental and interconnected building blocks is key to unlocking the full potential of this powerful architecture. Entities are unique identifiers representing game objects, like characters or items. Crucially, they don't contain data or behavior themselves. They are simply a unique ID that points to a collection of data. Think of entities as minimalist replacements for game objects, but without any default components, layers, or tags. This lean design allows for extreme flexibility and performance gains by only attaching necessary data. Components are data containers holding specific attributes for entities, such as position, health, or velocity. Each component is a small, focused piece of data that describes a single aspect of an entity. These components define what an entity is and its capabilities. They are implemented as C# structs, not classes, for efficiency. This allows for optimized memory layout and access, typically implementing the iComponent data interface. Systems are the logic that processes data stored in components, defining how entities behave and interact. They are the engines that drive the simulation forward, acting upon specific sets of components to update the game world. Systems operate on entities based on the specific components they possess, allowing for highly modular and efficient logic. This promotes clean separation of concerns and optimized data processing, as systems only interact with relevant data. Now, let's prepare your Unity project for DOTS. This crucial setup phase is essential for leveraging ECS capabilities, ensuring your environment is ready to embrace this powerful new paradigm. You'll need Unity 2022.3 or later and either the Universal Render Pipeline, URP, or High Definition Render Pipeline, HDRP. These provide the necessary rendering infrastructure for DOTS projects. Several packages need to be installed via the Unity Package Manager. This tool allows you to easily discover, install, and manage Unity-developed and third-party packages, extending your project's functionality. Essential packages include Entities, the core ECS package, Entities graphics for rendering, Burst for its compiler, Mathematics for optimized functions, and Hybrid Renderer for efficient entity rendering within Unity. Remember to enable pre-release packages in the Package Manager. Many DOTS components are pre-release versions, and enabling this ensures you access all necessary and up-to-date packages for your ECS development. Next, we'll create entities and components. This involves understanding how to define the data of our game objects, forming the fundamental building blocks of our ECS application. To create an ECS component, first create a new C# script. Right-click in your project window, select Create, then C# script, and give it a descriptive name. Then, replace monobehavior inheritance with the iComponent data interface. This marker tells Unity that this struct is an ECS component, signaling its role as a pure data container. Crucially, define the component as a struct rather than a class for performance benefits. Structs are value types, stored contiguously in memory, leading to better cache locality and faster data access for systems. To add a component to an entity, you'll use a process called baking. This acts as a bridge between your traditional game objects and the ECS world, converting components for optimized use. Baking converts monobehavior components into ECS components during the editor build process. This transforms your game object hierarchy into a highly optimized ECS entity world, ready for high-performance processing. Now, let's explore writing systems. These are the active elements that bring your entities to life, defining the logic and behavior that acts upon your entities and their data. Systems define the logic that acts upon entities and their components. They orchestrate how data is read, processed, and modified, acting as the brains of your ECS application to update the game world. There are different types of systems, including component system and system base. System base is generally the more modern and flexible option, leveraging the C# job system and burst compiler effectively. In a system, you define an entity query to select entities based on their components. This acts as a filter, selecting only those entities that possess a specific combination of components for efficient processing. You can then iterate through the selected entities and modify their component data efficiently. This direct and optimized access to contiguous data is a cornerstone of ECS's performance benefits, allowing rapid updates. The burst compiler is a crucial part of DOTS, translating IL/.NET bytecode into highly optimized native code. This process significantly boosts execution speed, making your C# code run much faster. Burst works in conjunction with the C# job system to significantly improve performance, especially for math operations. This powerful synergy unlocks unparalleled processing power for computationally intensive tasks. It supports just-in-time compilation, JIT, during development for quick iteration. For standalone builds, it uses ahead-of-time AOD compilation, generating the most optimized native code for maximum performance. To use burst, simply decorate jobs or static methods with the burst compile attribute. This annotation signals to the burst compiler that this code should be translated into highly optimized native instructions, unlocking significant speedups. The C# job system enables multithreading in Unity, allowing code to run in parallel across multiple CPU cores. This dramatically improves performance by fully utilizing modern processor architectures, preventing bottlenecks. This significantly improves performance, especially when processing a large number of entities. Many entities can be updated simultaneously, leading to much smoother and more responsive simulations in your game. ECS offers several key performance advantages. These benefits, combined with the C# job system and burst compiler, make ECS a compelling choice for high-performance game development applications. Its data-oriented design stores data contiguously in memory, reducing CPU cache misses. This means the CPU finds needed data in its fast cache, leading to vastly improved memory access patterns and overall processing speed. Systems can be easily parallelized across multiple threads, leveraging modern CPU architectures. This effectively utilizes multi-core processors, allowing for massive computational throughput by distributing workloads efficiently. Burst compilation generates highly optimized native code, further boosting execution speed. This native code is tailored for the target CPU, resulting in significantly faster execution compared to standard C# bytecode. These optimizations lead to significant performance gains, especially with many entities. This allows for richer, more complex, and smoother game experiences that would be challenging with traditional approaches. While powerful, ECS requires a different way of thinking about game development. It's a paradigm shift from object-oriented programming, and understanding this new mindset is crucial for success. It's important to understand the core concepts thoroughly. Rushing into implementation without a solid grasp of these foundational principles can lead to frustration and inefficient code. Be prepared to invest time in understanding the theory and experimenting with practical implementations. Hands-on coding, debugging, and seeing concepts translate into working game logic are essential for mastering ECS. Start with the basics and build a solid foundation in Unity before moving on to advanced ECS patterns. This structured approach will make the transition smoother and more effective for beginners. Practice with small projects and toy examples, then gradually apply ECS to larger, more complex use cases. This allows you to isolate and understand specific ECS concepts without being overwhelmed. A simple example involves spawning, and moving hundreds of cubes. This scenario clearly highlights the advantages of ECS over traditional game object-based approaches when dealing with high entity counts. In a traditional approach, you might attach a script to each cube to control its movement. This leads to significant CPU processing and memory overhead as the number of cubes increases. With ECS, you create a single system that controls the movement of all cubes based on their components. This centralizes logic and optimizes processing for mass entity management. This system iterates through all entities with a cube component and updates their positions efficiently. It directly accesses and updates data in a highly optimized, cache-friendly manner, demonstrating data-oriented design's power. Hybrid ECS allows you to use both game objects and entities in your project. This flexible approach is incredibly useful for various scenarios, especially during a transition phase from traditional Unity. This is useful for gradually migrating existing projects to ECS without a complete overhaul. You can selectively convert performance-critical parts while retaining traditional game objects where their workflow is suitable. The Entity Debugger window provides tools for inspecting entities, components, and systems. This offers invaluable insights for understanding and troubleshooting your ECS projects at runtime. This can be incredibly helpful for debugging your ECS code and understanding its runtime behavior. It allows deep visibility into active entities, components, and system execution, crucial for complex ECS development. While powerful, ECS isn't always the best choice. There are specific situations where ECS might not be optimal, and understanding these caveats is as important as understanding its benefits. For small projects, the overhead of ECS might not be worth the performance benefits. The time and effort could outweigh gains, making traditional game object approaches more efficient for rapid development. It can also add a layer of overhead to rapid prototyping, where speed of iteration is key. The structured ECS approach might slow down initial creative flow compared to immediate feedback from mono behaviors. ECS may also not be the best choice for UI and animation-heavy projects. Traditional Unity UI systems and animation workflows are often highly optimized for these tasks, and forcing ECS might add unnecessary complexity. Unity's ECS and DOTS offer a powerful paradigm for high-performance game development. They represent a significant evolution in how games can be architected, pushing the boundaries of what's possible within the Unity engine. By understanding its core concepts and applying them thoughtfully, you can unlock significant performance gains. This empowers you to create more efficient, scalable, and ambitious games, realizing their full potential. Thank you for joining this in-depth guide to Unity's ECS and DOTS. We hope this journey has provided a solid foundation and inspiration. Now, go forth, experiment, and happy developing.